good morning once more. I'm your trainer, Nitesa Mkali. I'll be taking you through survey 1. Our topic today is circular curves. Circular curves. Before I continue, let me take the roll call. Elkanah Zablon, present. Brian Diagon, yes, present. Diagon, present. I can see us all present. Let's continue. Okay, on circular curves, we are going to look at simple curves, and how to set them up. Simple curves. What's the date today? The date today is 27th October 2025. Now, as we learn on specific objective will be by the end of this lesson. By the end of this lesson, a learner should be able to set out circular curves using an offset from the long chord method. Now, with curves, for instance, when curves are used when turning, for example, assume this is your road. Yeah, the road is turning on your left or right, the way. A curve is used to make the corner smooth so that vehicles can move on a smooth way. Now, when you are setting up a curve, the first tangent comes through here, the center of the road, and the second tangent comes through here. Now, you have to find a place where the curve touches the tangent. Now, you join this. And this. Then this will be a center. Now, long chord will be where the curve touches the tangent, both sides. That is your long chord. When we say offset from a long chord, this is the long chord here. This is the long chord. This is the offset we are going to use. This is our road. This is our road. A bending road. Yeah. As I talk, I think you now understand what I mean. This is just a sample. Our curve will be somewhere here, so that the road can pass somewhere here to make the curve smooth. Now let's go to practical. That was just a sample of an example. We assume this curve looks like this. Then this is the long chord that we are supposed to use to get the offsets. Our move intersection is here, theta. Our radius is this, offset assume our curve is something. This is our tangent. This is our long chord. And this curve length. Now we want to calculate. We all know the formulas for this. Finding the tangent, finding this distance, and finding this distance. Now we want to look at how these formulas come to action. Yeah? First, before we continue, let me write the formulas here so that we can calculate each formula on its own. Tangent. The formula is R tan theta. R is R, yes. For the long chord, our formula is 2R. 2R sin theta over 2. I think that's right. Let's look at those two first. We want to see how we find these formulas. Are you listening? When finding these formulas, you only pick one triangle. Talking about this triangle. This triangle will give us everything. Yeah? This is the triangle we are talking about. We are trying to interpret these formulas to understand how we find R and theta to be the formula for the tangent. This triangle. Now just extracted this triangle that we can use it to find our distances. Assume this curve passes through here. That's what we assume. So this is the R. All know that. This is the tangent. We don't know the tangent. And this let's name this distance OC. You know this is a right angle. When you have the right angle, you have one side, you have everything. So first of all, we stick to that formula of ours so control. Now we want to find the tangent. The tangent. Which side will we use when we want to find the tangent? So this tangent is the opposite. We have the adjacent here and the hypotenuse. Now this is our angle. Angle. Let's assume our angle is something. Let's just call it theta. Make the work easier. Yeah? Now, are we using slope or curve? Because we are trying to find the opposite. There's only two formulas you can use: the torque and the slope. Now here I choose the torque. So it's T tan theta equals to opposite of adjacent, right? Which is tan theta equals to opposite is T, our tangent, and our adjacent is radius. Unapata. Now let's try to make T as a given formula. Tan theta is equal to T all over R. We multiply both sides by R. Our T will be R tan theta over 2. We say over 2 because the whole triangle was theta. Now this means this one is over 2. Half of the triangle. Tumeshapata formula ya kwanza. Formula ya tangent ni R tan theta over 2. Ndio hiyo tumepata. Haya. Let's find this distance. Find this distance. Distance 0. Hypotenuse. hypotenuse, sine or cosine. For me, I'll choose cosine because we know our adjacent is r and t is a long formula, so we use our adjacent which is r. So cos theta will be equal to adjacent over hypotenuse. Cos theta will be adjacent is r over hypotenuse, which is cos theta over 2 will be r over hypotenuse. We want to make a hypotenuse subjective to the formula, we multiply by both sides. Yeah. We'll find that hypotenuse cos theta over 2 is equals to, no, I'm going wrong. Okay, it will be cos theta over 2, that's half the triangle is adjacent which is r over and make hypotenuse subjective to the formula. Multiply both sides by hypotenuse. It will be hypotenuse cos theta over 2 is equals to radius. Now we say we want hypotenuse to be the subject of the formula. We are still going on. We multiply both sides by cos theta over 2. Cos theta over 2. Cos theta over 2. Yeah? Now hypotenuse will be equal to r over cos theta over 2. Now 1 over cos theta is equals to sec theta. This will be r times 1 over cos theta over 2. Cos theta over 2, which is hypotenuse will be r sec theta over 2. R sec theta over 2. Is that right? Okay. I'll find the formula of all this. Now, this is the formula of hypotenuse. This distance from O to C. We don't need that distance. What we need is this and this. These two distances. Let's call this distance M and this distance I. Okay. Now, after finding this for all this, to find, let's say we want to find the I. The I, formula for I will be all this distance minus the radius. True or false? This distance inafika hapa, radius yetu inafika hapa, na distance ni hiyo. So ni hii yote, this formula r sec theta over 2 minus r inatoa r radius inabaki hapa. So we have the formula of this I. Our first formula was for t, which is r tan theta over 2. Our second formula for this I is r sec theta over 2 minus r. That's our second formula for this. Now I want to look for m. Our distance m. Now distance m is from here to here. And before that, let's find the long chord. The long chord. Now long chord. Long chord. We have this distance t, and we have our long chord, and we have this. Our t, our this, and this. Now we are going to use this small triangle. I can just take it here. Triangle. Now this is the right angle. This one. And this is the right angle. This opposite. This and adjacent. This and opposite. Okay, I'm trying to find opposite. So I think I will use. So the same formula. Same formula. I'm trying to find our adjacent first. So we use the adjacent. You can either use this or this. Let me choose to use cosine. Cos theta is equal to adjacent by hypotenuse. Our hypotenuse is T. Our adjacent we don't know which is the long chord. I mean half the long chord. Not yote ni hivi, lakini sasa hivi half. So cos theta over 2 will be adjacent, which will just be adjacent over hypotenuse, which is our T. So in a both sides by T. By T was theta over 2 equals to adjacent. But this adjacent is half, so it's by 2. 2 it will be, adjacent will be the formulas. I think we know all the formulas right now. So we go back to now recalculation. Ili kwa tu ya kujua vile hizo formula zinapatikana. As long as you know the formula, you are right where to go. But as an engineer, you have to know how the formulas come into action. And we all have seen how the formulas come to action. Now, we're going to use one example. We assume our angle of intersection will be, assume let's use something like 40 degrees. Our radius, we use 100 meters. Labda you're gonna have 100 meters. And our tangent, the ground will be using a theodolite to measure the measurements for the tangent and the position of the intersection. Now tangent, let's use 200 meters. Won't make any sense. Let's use 80 meters. You want to find the long chord, you want to find the length of the pulses from the long chord. Length of the distance from the long chord. Now, first we know the tangent and we know the radius. Now the formula for this offset. Must find first the first step. Let's find the length of the long chord, which is long chord equals to R sin theta over 2 from the formula. 2R. 2, our R is 100 meters times sin theta. Theta is 40 all over 2. Can you use your calculators, please? Our answer will be 68.40. Number 10.40 meters. 10.40 meters is the length of the whole long chord. But for us, it's just some uniform thing, so we are going to play with one side. We divide this long chord by 2. It means you divide this 68.40 by 2. Yeah. Which is at 4.20. 4.20. That's the length of our long chord. Okay. Now we are working with this at 4.20. That's our offset. That's our long chord, I mean. This is the only thing that is going to help us find all these distances. The first thing we will find this offset, this first offset, which will be our guide. First offset O will be R, yeah, minus square root of R squared minus length, which is C over 2. The C over 2 is this distance. Now C over 2 will be half of it. Okay. Now let's start. Our first offset, offset 1. We'll divide this offset into several numbers so that each will cater for all distances. The first distance will be 10, 20, 30, and then the final one will use this 4.20. 4.20 because it's the smallest and tunajua curve hapo mwisho inakuwa short. So hapa itakuwa even shorter than the other side. Now let's start with the first one. The first one is 100 minus square root of 100 minus distance 68. I mean, let's just use that because we know that the C over 2 is 34.20. 34.20. Okay, 100 minus. That is 100 minus 34.20. 34.20. 25 point. Look at the data of square root value. 65.8. Now square root answer will be 8 point. 8 point something like 8 point. 100 minus answer 91.8. 91.8. It doesn't make any sense. I think it's because I used the guesswork. I used guesswork in this name. That's why it's making these all differences. But let's go on. I know I went wrong. I did square 100. So I'm sorry for that. 100 squared will be 10,000. 10,000 minus 34.20. 10,000. 0.20. What's the answer? It will be 99,000. I mean 9,965.8. When you square root the answer, it will be 99.820. Now we take 100 minus the answer. It will be 0.171. Now 0.17 is the first distance here. Here will be translated of answer. Okay, we use the same formula after this one because you have found this one. Use the same formula here, and here. When you calculate, you'll find these distances are reducing. As we move to the edge, they reduce. That's how the curve comes from tallest to smallest. Now, the same formula we use on this other side to find these distances, they will be the same on the opposite side. So the curve will run and our road will be smoother after that because we have reduced the curve to a certain level that everyone can use the road conveniently. That's all about the curves. We have other formulas to calculate this curve, but today we measure them offsets from the long chord method. I think everyone can do that practically, yeah? You have understood the way we come along with this. You all know how we make this formula. So on the ground, when you assume you are having a road project, you'll be able to calculate these offsets so that the curve can be constructed. Now on your assignment, yeah, on your assignment you set off assignment. Assignment instead of 12 circular curves using the offset from the long chord method where the radius is 80 meters and the tangent is 100 meters and our theta will be 30 degrees. Go up on that, it will be 10 marks. Continue. Okay, this is our assignment, and for reviewing our what we have learned, I want to mention each one of you as you come and show me the component that I mentioned. Okay, I need someone to come and show me the radius. Elkana. Enoch, show me the radius. The radius of the curve. Is it right? The radius of the curve? No. The radius of the curve is this distance to this distance. This is our radius. Okay? We correct on that. Our tangent, Diego, tangent. That's right, that's our tangent. This 80 meters is our tangent. Now the final one, I need someone to come and show me the formula of finding the tangent. Formula of finding the tangent. Formula of finding the tangent. Okay, so just show me the formula of finding the tangent. Formula of finding the tangent. That's right. Our formula of finding the tangent understood. Yeah. In our next lesson, we'll pick from there.